So we use machine learning in our models.
Yeah.
We build models. A lot of people in the audience have been using and building machine learning models. And then for the rest of us, we've heard about it too much. We think we get it. We saw a whole bunch of YouTube videos and we figured it all out. But there's this computational problem of machine learning models. So walk us, what is machine learning model? And what has been the evolution of ABM combining with machine learning models versus traditional straightforward algorithms back in the 90s and 2000s?
Yeah. So machine learning, I think, just take a step back for everybody here, right? It's a part of artificial intelligence. Artificial intelligence is the idea of how do you get sort of, thinking outside of human beings, right? To sort of simulate, help us out, do a bunch of things, so on. Machine learning is specific to machines, right? How do you actually get machines to be intelligent and so on and so forth? And that's where a lot of, focus has been over the last few years. Deep learning is a part of machine learning, right? And how that happens. Now, there are many approaches to machine learning. Fundamentally, it's about how do you take something outside of me to be intelligent and help me out to do whatever. It's as simple a task as maybe do my laundry, or it can be as complicated as send somebody to Moon and Mars and things like that, right? So that's what machine learning is. Now, when I think about agent-based modeling and machine learning, for me, agent-based modeling in some ways is very simple. It's about bottom-up, right? Now, historically, what's happened is, if you think about the agent itself, we've actually not given agent a lot of credit. We've put rules around it.
Rules.
We've put sort of environment which are complicated. We tell how it may interact. We don't say much about the agent. It could be a dumb book or a pen or whatever it is. It's all going to do the same thing. And to me, where the next evolution of this is, can we put some intelligence inside that agent?
Yeah.
And this is where machine learning comes in. And here is where it's ironic in some ways. If I think about a lot of machine learning model, a lot of people would argue it's statistical. So in some ways, statistics is going within an agent. And that's going to happen. That's always going to be the thing, where you're going to go into smaller and smaller pieces where a lot more things can be developed in an agent-based fashion. And until then, we have these machine learning models, these statistical models to help us out in the meanwhile, right? So I think of this as getting agents to be a lot more intelligent. Now, where does it matter, for example? So I was reading this, I think it was a YouTube video. This happened, I want to say a couple of months ago, where they were trying to solve the problem of congestion in Texas, I believe, or something like that. They said, hey, there's a highway, there are 3 lanes or something like that. It's very congested. What do we do? Top down, let's add just more lanes. It just makes a lot of sense, right? More cars, more lanes. Do that. They did that. It actually got worse. And they were like, how does that work? And what they didn't realize in some ways is like, hey, there's this idea of induced demand. We forget that there's a feedback. To whatever you do, there's a feedback. And when you don't think like that, that's when you think about a human being or an agent, there's this idea of a feedback. What happened was, when you expand lanes, people who were actually taking trains now want to drive, and you overcorrect for it. It got worse. In fact, the last I saw in Boston, they took away a highway and improved the traffic in that thing, because a lot more people, it just got so complicated that people started taking the trains from that standpoint. So again, the idea is, we never usually think of feedback because it's really hard to think about it. We can always say, hey, when this happens, I do that. But what's the impact of that back? How will the other agents respond and do that, right? And machine learning is starting to do that. If you think about AlphaGo and a lot of these things, which fundamentally are saying, I can actually think through what my opponent is going to do and figure that out, can preempt it. And I can do this better than a human for that particular thing. And that's where that intelligence goes. To me, it goes inside an agent, and that becomes a lot more interesting and exciting.
So there's a computational problem.
Yeah.
So it's hard enough to run a machine learning model with huge amount of data.